I'm Patrick Bailey with iQless. Today is May 30th, 2022, and in this video I'm going to go over the iQless lemon battery. Okay, let's show some URLs real quick and talk through it, and then we'll actually go show it in action. So I did this a long time ago, long time ago. I have to go see the year. You know what? I actually probably have it here because I got the video. 2019, so it's been 3 years. Wow, okay, so it's been a while. And also I had a big beard back then. So going to the URLs, here's the iQ lemon battery that's out there on Printables, and the link will be in the show notes. You can go download all the files here. One thing to note though, if you're doing a lemon battery, you use lemon juice in this case. You do need copper coins, copper pennies, because I'll show you how they fit in real well on here. But also you need zinc. You need zinc bolts, and I have a link over in the show notes here on Home Depot. Here are the zinc bolts that I'm using that thread in just fine. But also the zinc is sacrificial. So this will work for a while, but then the zinc coating will wear off, and then you'll have to get new zinc bolts. So this is it's not going to last all that long, but it's good to teach kids how to do lemon battery stuff. And then also I did a video a long time ago, 2019, where I put this out there, so you can actually go watch that old video where I had a really big beard at the time. So there's the URLs, and let's talk through this real quick. So if you I put a 3MF file out there, so if you slice this yourself, you can do one color, but I would advise you to put a couple of change points here. I see at 11.3 and at 12.2, and what that'll happen, that'll get you this result so kids can more easily see the plus and the minus, the zinc, the copper, and I put a little lemon battery there, so it's kind of cool. Also, a nice thing about putting a different color there, like black, I think, yellow and black, it's lemon, right? Is you end up accidentally, this was not my original plan, you get this fill line. So you get a line right there that you can use to fill up the lemon juice, which you don't actually need that much, but, well, maybe you do because the zinc has to hit. But that gives you a nice little fill line so you don't overfill it. Also, I did design this for my homeschool at the time, and I taught my kids some electronics, but I also designed this with teachers in mind in regular classes. So what this actually can do, and I'll demonstrate this when we do it, is this is stackable. So you can make as many as you want, you can stack them up. They're relatively easy to clean. That was the idea. Now, when you're cleaning these and they're PLA, do not put them in a dishwasher. If you do, the PLA will distort, melt. It's not made for that kind of temperature. And also right here, you can see there's a little gap right here. And that can be used if they happen to get stuck, you can pull them off. So there's a lot of, I like this design. I worked really hard on it. And I think it's pretty cool. And actually, I bring it every year. Ever since I made it, I do bring it to the homeschool conference, and I sell a few of them and show them off. And I've had a couple of teachers grab 3 or 4 at a time sometimes to bring to their own classrooms, because there's a lot of people who are homeschoolers or who were former homeschoolers who actually teach in the public school or know someone who does. So that was the purpose between all this. So now, with that, let's go demonstrate it, and then go over some of the numbers and such. Okay, so here is the lemon battery. We'll give it a good little look here. Now, the yellow I'm using kind of didn't show up as well as I'd like compared to my old yellow, but it still looks okay. Now, the idea behind this, like I mentioned before, is they're also, sorry about that, they're also stackable. Let me get some of this, we'll just show this stackability. So, they can stack one on top of the other. And if you have to, you can wedge them out. So that way, if a teacher had a bunch of them, they could just stack them all up. So with that, let's see if I can, it's been a while since I've tried one of these. Let me see if I can get this to work. So the idea is you need copper, and the easiest way to get copper is copper pennies. So they actually snugly go in there and get pinched. So they should hold just fine. And I put 2 rows in so teachers could show different experiments of in series and parallel. Does it matter? What can you do? But for a basic experiment, you just need the 4 pennies. So we'll do that. And then we'll take these zinc bolts, which are sacrificial, like I mentioned. And the nice thing is you can thread them in. It's a lot better to do, I like the idea of handing this out to a bunch of students versus lemons and zinc nails like people do, and I'm sure that can always I'm guessing that could cause some problems in school. But also this is kind of, it guides you. It says, copper, zinc, positive, negative. So it gets that whole idea across. So I'm rather proud of this design. Okay, so take a bunch of alligator clips, and then what you'll do is you go positive to negative. So I'll say positive here, and hook that to the zinc, and then we'll say positive here, hook this to the next zinc, then we'll say positive there, hook that to the zinc, and then now this will be my positive out here, and then my last zinc. And then I have a bunch of LEDs, little small ones, and let me see if I can remember my electronics correctly. If you look at LEDs, they'll have a longer pole, if you can see that.
Just put on the white.
And if I'm remembering correctly, the longer one is the positive, if I'm thinking correctly. If not, we'll learn real quick, right? So I'll attach the positive over here to the longer one. Now they can't be touching, of course, so I'll spread those out a little bit. And then connect that up. Okay, let's see what we can do. Now we got lemon juice, just nothing special. You can buy a bunch of it at the grocery store for cheap. And we need to make sure, that it's hitting that copper, the copper and the zinc. Okay. And let's see if we have light. Look, light. I don't know how well that shows up. I can cover it in darkness. So I have lemon power. So there you go, a lemon battery. So a good thing for homeschool, good thing for regular school. Also, I remember one person asked me years ago, does the lemon erode the PLA? No, I took, maybe over years and years, maybe it might, but I did take, as an experiment at the time, I took it and put a bunch of lemon juice in it and left it out in the garage, and the lemon juice evaporated long before it did any damage. So I imagine in a classroom setting, you're not using these all the time, they'd probably last years and years. But I think I said this before, it's PLA that I made this in. You don't put this in the dishwasher. You're gonna wash this by hand, otherwise you put it in the dishwasher, you're gonna have a big, it's gonna melt or something, it's gonna deform. So with that, we have light. And it's not gonna last long, and I'll say it again, the zinc is sacrificial. So it's gonna wear out, and you're gonna have to get other bolts. So there's that. And with that, we'll go over the numbers and details. Okay, let's go over the numbers. Just the PLA print numbers, not the lemon and the pennies and the zinc. All that is a little bit extra. So to print this guy out, it takes 12 hours and 3 minutes. It takes 10.4 cents with electricity, and it weighs 0.108 kilograms, and at $20 per kilogram comes out to $2.16 with the material. So all in, $2.27. Just for the plastic. So I like this model a lot. We tend to sell a couple at the show. Not a lot, but I think it's a really good model. It's a lot of fun. So there's the numbers. And the pennies are pretty cheap. The alligator clips, you can go buy those on Amazon and buy them in bulk. Now, I think we sell them at the show for about 15 bucks as an entire kit. So you can put that in perspective. I didn't remember, I did the calculation a long time ago. So you're probably, if you're gonna make a bunch of these and have everything, you're probably talking, for probably 5-ish, 6-ish bucks to get everything you need. But then you got to remember the zinc is sacrificial, so you got to remember that you got to keep buying that for your experiment. So that's going to probably be your major cost over time is the lemon and the zinc. But the rest of it you can reuse, one time cost, right? Okay, so with that, let's wrap this up with a reminder that 3D printing is an engineering adventure you're on. You can develop your skills and knowledge. You can take this in so many ways. You can make a business out of this. You can teach others. And you can make some amazing designs. And you can make some amazing designs for education. So design it, engineer it. If you are like me, busy in your own head with your own design ideas, take a break today. go peruse through Printables.com and find an interesting print or two to print. A lot of good ideas I've had have been inspired by other people's designs. Some ideas I would never thought of doing had I not printed someone else's design. And hey, if you do that, post a make, it makes the creator feel great, and you get some Prusa points for it that you can use to apply to a free roll of filament.